All right, so this is the second part of 6-7, and this is called geometric series. So if you remember last time we did a sequence, which a sequence just um, finds the next number. So you have like a pattern, but remember it has to be a certain pattern where you're always multiplying to get to the next term. So if I start out with 3, if I start out with 3, then I went to 6, and I went to 12, and I went to 24. That would be a geometric sequence because I'm times by 2, times by 2, times by 2, right? So the series would be when I add these all up. Now, the problem is you can't just add anything like a geometric series because these things go on forever. So what we call it a finite geometric series where we have an ending point. So if I said add the first 10 terms up, so I'd say the first 10 terms, that would mean you're going to add up the first 10 all together. We can't just add up the geometric sequence or series because there's never an end, so it wouldn't work. So there has to be a finite. All right, so it's the sum of all of them, and this is the formula for it. We're just going to go over some of these things right here. A1 would be your first term. R would be your common ratio. N would be how many numbers you're going to do it to, like the 10th, and R is still the common ratio in this. R is not allowed to be 1 for this. All right, that's it. You're just going to use that formula, plug in and chug. Sometimes they'll give you the Sn, and you might have to solve for R. Sometimes you might have to solve for A1, but you just use your algebra skills to isolate that variable that we've done all year long. So they have to give you all of them except for maybe one of them, and you can solve for it. So here we go. All right, write an expanded form of this series. What is the sum? So the expanded form would say that you're going to write it all fully out. So that means you're going to get all 7 terms, and then you're going to add them physically together. That would be a pain in the butt because when we add fractions, we have to have a common denominator, and that's not going to be fun to find in all of these things. So it's going to be much better to use this formula that we get to use eventually down here. But expanded form would be just showing everything that's chatting. So you would literally put 1 into this, and you would get an answer. So you put a 1 in, just to show you, you would get 1 minus 1, which is 0. 2/3 is 0 is 0. Or that's 1, I'm sorry. And then 3 times 1 would be 3. So that's how they got this 3. Then they kind of like, all right, reset, erase again. And now we're going to go to 2. So we're going to plug in 2 here. So 2 minus 1 would be 1. 2/3 to the first power would be 2/3. And then you have 3 over 1 times 2/3. And this 3 would cancel out, leaving you with the 2, which is exactly what they got there. And then they just did that for 3. And when they did that, they got this. And then they did it for 4, and they got this. 5, 6, and they did it all the way to 7. Why did they stop at 7? Because that's that number right there. And then what they did is they checked their work, or they got an easier answer by just plugging into the formula that I showed you up above, which was that A1 1 minus R to the nth power all divided by 1 minus R. And that's what they plugged in. You can see A1 is the first term. That's right there. Your common ratio, if you look back here, this is the formula where you have A1 R to the n minus 1. So you can get your R from here, which is what they did. R was the 2/3. That's right there. That one right here. And then since we're going to 7, that's the highest. It's going to be how many terms there are. So that's what they did that. Okay. Next, how many terms are there in this geometric series? And actually, this could be really a sequence or a series question because they're not actually asking us to add them all together. They want us to figure out how many of these did they actually add together. So if you look, they didn't actually use the series formula. They used the sequence formula. And they said, hey, I know the last term that I used. I know my first term. I know my common ratio is 1.5. The way they got that is they just took 300 divided it by 200, because how you get from one term to the next term is going to be your common ratio. When you do that, you get 1.5, so that's where the 1.5 came from. And then they had n to the first. And then what they do is they use algebra to get this thing all by itself, right? So what do they do first? They divide this side by 200. And that cancels out, and then you have to divide this by 200, and that's where they get this number from, right? Whoops. Oh, crap. Delete. All right, sorry. All right, and then when they got to this step, what did they do? They go, oh, we need to get that n out of that numerator, so what we can do is log both sides. And that's actually a thing that we didn't do in logs, but they pull that in now. We're actually going to skip that problem. Sorry. I'll talk you through it a little bit. There's a rule that tells us that when we do the log, you can actually pull this from here up in front. So a log rule. Then right here, when you have these multiplying, they divide each side by log 1.5. That's where they get this from. And then they add 1. And when you do that, you get about 10. That's a process. You won't have any of those on the test because I didn't teach you that trick. That is the process. And finally, if they said, hey, here is the sum of the geometric series, so you know the sum, you know the Sn, right? And they said the first term of the series is 3, so you know the A1, which is right there, right? That's where they put the 3. And then the common ratio is 5, so you know the R. How many terms? You're looking for the n again. And so what they do is they plug in all those things down. So that's all they did right here. It's just plug in, right? And then they said, hey, 1 minus 5 is a negative 4. How do I undo dividing by a negative 4? I have times. So they times actually both sides by a negative 4. That cancels that out. And when you times this side by a negative 4, that's where you get this number from. And they say, hey, wait, we need to get rid of that 3. So we divide each side by 3. So they divide by 3. And that's where they get that number from. And then after they divide by 3, they say, wait, we want to get this by itself. So they do a couple steps here. They minus 1, minus 1. So you end up with negative 1 minus 115,624. And that should equal a negative 5n. And I know you don't see that because then they say, hey, we don't want a negative, so we times everything by negative 1. So times by negative 1, times by negative 1, times by negative 1. And that becomes a positive 1, a positive 15, and a positive 5n, and that's what they get right there. And then they use that trick again to say, hey, we need to get something out of the numerator, or out of the, not numerator, out of being an exponent. We don't like this n right here being an exponent. So what they do is they know that you can use log rules to pull that down. So they log both sides. That's what they did. And then, like I told you before, you can pull that in front of it. That's what the trick is right there. And then to get to the n by itself, you'll notice that they have n times log. So all you do is you divide by log 5, and that leaves you with the n by itself. And when you do this in your calculator, you get about 6. So try that, see if that kind of makes sense. And we'll kind of go from there. I'll try to pick some homework that doesn't have too much of that. I might give you some of it because I did explain it a little bit. Will not be necessarily tested, maybe a bonus question or something like that. But yeah, the rule is, it's not hard. The rule is right here, when you have log 5n, this exponent, you can actually move it in front and multiply it. So it becomes n log 5 like that. And that's n times the log, and that's why they divide by log 5. So that's the rule. Whenever you have something in an exponent with log, you can actually pull it in. You can do it any other time. The only time you can do that is if it's in a log. It's a rule that happens. All right? So hopefully take those notes, get that to me. We only have a couple more days left of this online stuff, guys. And then we'll be home free into summer. So I hope you guys are doing well and understanding my videos. Make sure you come to the live chats. If you're not, I haven't had very many people showing up to that. So if you need help, don't hesitate to show up to the live sessions. Other than that, have a great night. Take these notes and upload them.